Okay, so hello everyone, welcome. Can you hear me?
Yes.
Okay, so that's we're waiting 1 minute, then we'll start our session. Okay, so we'll start today's session. So basically, today is our second days of online training program on 7 days for Google Earth Engine from beginners to advanced level, and we already complete our first days. So after completing the total 2 hours live training session, then I will move to that 1 hours problem solving class. Okay. So you all of you all just simply share your screen and then show your problem. Then we discuss after completing the 2 hours live training session. We discuss about the problem solving class. Okay. So now I just simply share my screen and we'll start our today's session. So let me share my screen. Now, okay, can you see my screen? Okay, thank you. Okay, so now let's go. So basically today I try to discuss about that how we can easily filtering and displaying the satellite images, mainly Landsat, Sentinel, or MODIS. Okay, all of satellite images, how we can easily filtering and displaying in Google Earth Engine platform, and how we can create the different types of satellite image composite, and how we can easily use the different types of band combination. Then how we can easily export the satellite imagery. It can be Landsat, Sentinel, MODIS. Okay. And then how to import, filter, reduce, clip, and display the raster data in Google Earth Engine platform. How to make the time series chart of any indices, not only for the NDVI. I will show you the example with NDVI, but using the same approach, you can easily do for any kinds of indices for making the time series chart, and how we can easily export the any shape file from Google Earth Engine platform. Okay, so let's go. Let's start one by one. So basically, Earth Engine public data catalog provide you a lot of data set freely available. We can easily get Landsat, Sentinel, MODIS, Train, different types of land cover data set, atmospheric data set. So there's a lot of data set we can easily access freely, and this data set updating daily. Okay, and this is the link about this data set. So basically, when you go to this link, it open all of data set. Okay, suppose I just simply go to this link, or if you want, you can also open your code editor. Suppose simply go to this link, code.artengine or google.com. Simply go to your code editor. From the code editor, we can also access the Earth Engine public data catalog. I simply click on the continue. So now my code editor will be open. And from here, I can easily access all of dataset. For accessing all of dataset, for that I simply click on the search place and dataset. Here you can see. Just click on the browse data catalog. Okay, just click on here. So now it open all of dataset in Google Earth Engine public data catalog. So here we can easily find out all of dataset for the climate, weather data, surface temperature data, atmospheric data, weather data, different types of imagery, Landsat, Sentinel, MODIS, different types of high resolution imagery. Okay, There's a lot of data set we can easily access from here, and we can easily use this type of data for our different types of analysis. Also, you can see, click on the Landsat, then you can get all of Landsat image collection for the different time period. We find out the Landsat 9, Landsat 8, 7. So all of Landsat image collection we can easily access from here. You can see Landsat 9, Landsat 8, Landsat 7. Also, you can see the Landsat 1 to 5, 4, Landsat 5. So all of image collection for Landsat you can easily access from here. Just I click on the Sentinel, then I get all of Sentinel image collection. For the Sentinel 1, Sentinel 2, Sentinel 3. So all of Sentinel 5, all of Sentinel image collection I can easily access from here. Okay, you can see 2.8. Second is Sentinel collection. You can easily get the Sentinel 1 star data, Sentinel 2 multispectral instrument, Sentinel 3, also you can see about that, Sentinel 5 PROPOMI, tropospheric monitoring instrument. So all of image collection we can easily access from here. Same as MODIS. When you click on the MODIS, then we can get all of MODIS image collection for the different types of MODIS product, such as evapotranspiration or NDVI or EVI, or all of MODIS image collection we can easily access from here. Okay, here you can see it appeared. For that, all of MODIS collection in Earth Engine, we can easily get the lot of data set. Okay, so you can see the Terra vegetation. Also, you can see the Terra land watermarks. So Terra ocean reflectance daily, Aqua ocean reflectance daily, MODIS land cover data set, MODIS land cover yearly data set. So there's a lot of data series available for that MODIS. Okay, so now we talk about that. Okay, so basically this is the Earth Engine public data catalog. If you want, simply click on the browse, you can see browse data catalog, then automatically open the link where you find out all of Earth Engine public data catalog. So in this time, I just simply back to my slide. So now we talk about that, how we can easily filtering and visualizing the satellite images in Google Earth Engine platform. Okay, so basically when you filter your image collection, it depends on some condition, it depends on some factor. Okay, when you filter the satellite image for any study area. So for first of all, you just simply selecting your study area. Suppose you want to filter, you need the satellite image for a specific boundary. So you can simply import your boundary shape file. Suppose I need the image of Dhaka city. So I just simply import that Dhaka city boundary. Okay, so which boundary or which area of interest you need the satellite images, you just simply import your study area. So it's one kind of factor for filtering your image collection. Second factor, it's called the image metadata. Suppose I need only for those images, which image will be not more than 1% cloud cover. So it's the another factor. Suppose some region such as coastal area or river bank, you did not find out that less than 1% image. So that you have to increase the cloud cover value. Further, suppose you need this image only for the specific boundary, such as you need the image for year of 2017 for dry season, summer season, rainy season. So when you filter your image collection, it just depend on some factor. Basically, three factor. Why you need this image? I need the image Dhaka city. How you need the image? I need the image less than 1% cloud cover. And when you need this image, suppose I need the image for year of 2017, month of January, or summer season, or rainy season, or any time period. So when you filter any satellite images in Google Earth Engine platform, so basically it depends on the three factor. First factor is that region of interest, which area of interest you need this image. I need the image for the Dhaka city. So just I simply import my Dhaka city boundary shape file. And I need the image which is the less than 1% cloud cover. So I simply filter. I get only for this image which image will be not more than 1% cloud cover. And finally, I need the image for year of 2017, suppose rainy season or any specific month. So now try to check about the practical example, how we can easily filtering. So for that, I simply open my code editor. So just I write the code in here. And first of all, you try to understand all of this code, okay, not write at the same time, then you can get the problem. So I will send you all of code. So that's why when you, after completing this class, you try to use the code and write the code. Okay. So at the same time, when you write the code, you face some problem. So in this time, just listen to my lecture and also understand all of function, how it will be worked. Okay. So let's go. So in this time, suppose I want to work for the lens set. I simply click on the lens set. So here you can see we find out all of lens set image collection, such as lens set 9, lens set 8, lens set 7. So basically it's a different time period. Lens set is available from here. Also you can see lens set 8 is available from here. Lens set 7 is available from here. Okay, we also get the different time period for the different lens set image collection. Okay, all of image collection is the same process when you filter. It's the same process. If you want to learn how we can easily filter in the lens set 8, this same approach you can also apply for the lens set 7, lens set 9, lens set 5, lens set 4, same approach when you filtering. Okay, suppose you just learn how to filter lens set 8 image collection, you can just apply for lens set 9, lens set 7, lens set 4, lens set 5, any image collection. So let's check. I show you example for lens set 8. I just click on here. So now I can get all of those things here. You can see about that surface reflectance imagery, top of atmospheric imagery, and raw image. Okay, so in this time, raw image, so basically which image we download from that different sources, such as without any kind of correction. Okay, so raw image, it's without any kind of correction, but top of atmospheric image collection and surface reflectance image collection, it has some correction, such as atmospherically corrected. You can see it also about the atmospherically corrected surface reflectance image. Okay, you can see calibrated top of atmospheric reflectance. So this type of imagery, top of atmosphere or surface reflectance, this type of imagery is some correction already done. So that's why when you want to use the top of atmospheric or surface reflectance, then we don't put any kind of correction. We don't need any kind of atmospherically correction or other correction. We don't need. Okay, but when you want to put the raw image, then we have need to this type of correction. So in this time, I will show you that top of atmospheric and surface reflectance. And top of atmospheric, basically it used for different calculating different types of indices. Okay, it's very useful for calculating the different types of indices such as NDVI, NDWI, EVI, or SAVI, or any other indices. When you want to do, then we use the top of atmosphere. And surface reflectance, it's very popular to make the land use land cover mapping, then land surface temperature monitoring. So these type of things we are using at the surface reflectance satellite imagery. Okay, both are the same process for filtering. Suppose I just simply click on the top of atmosphere. So now I can get all of information about my imagery. Here you can see, first of all, dataset availability. Okay, so we can get the dataset from year of 2013 0318 from this time, and 2024 you can see that 10 May. Okay, so it also updating daily. Okay, so now it's the update imagery from this time we can access from this Landsat 8 top of atmospheric reflectance image collection. And you can see dataset provider mainly USGS and Google. And this is the art engine snippet about that. Art engine snippet, so basically it's an unique ID of any image collection. You can get this type of unique ID for any image collection. So basically it's a unique ID of this top of atmospheric reflectance for Landsat 8 image collection. We find out all of images have this type of art engine snippet. All of image collection, all of dataset, we find out this type of snippet. It's called the unique ID of this dataset. So now this dataset I want to import in my code editor. So this is my code editor. So how I can import? Very easy. Just you can simply copy the unique ID. Simply copy this unique ID and then paste on your code editor. Okay. And now this is my image collection. Okay, of Landsat 8 top of atmospheric Landsat 8. So now just give a variable name. I simply increase my, then it also more better. So then I simply put a variable name. Okay, you can put any variable name, and we already know about that, how we can easily define the variable in JavaScript programming. Before the variable name, just put the var keyword. Okay, and then put the variable name. Variable name can be anything. You can put any name. Suppose I put the name is the L8. Okay, then equal sign. So now what happened? In this time, this is my image collection, and this image collection I stored in a variable. This variable name is the L8. Okay. So now this L8 is stored all of image collection of Landsat 8 top optimosphere. So now I want to check how much image is available in this image collection. How much images are available. So for that, I just simply use a function print. So I want to print this L8 because L8 is stored this image collection. This image collection is stored in the L8. Now I want to compute how much images are available in this image collection. For that, I use a function, size function. Okay, basically size function computing how many images are available in a collection. So now click to the run. So now it's computing how many image collection or how many images are available in this image collection between this time period, year of 2013 to 2024 for the whole world. So now it's computing. So now is it computing this result. Okay, so here again, so you can get the entire very large number of image collection, more than 1 million. We find out this type of image collection in here. Okay, and this is the result for the whole world between this time period, year of 2013 to 2024. Okay, so it's the full image collection. How much image we find out? We find out this number of image collection in here. So now this image collection I need to filter. Okay, so now how I can filter? So basically we find out total 3 factor. One is the region of interest, then image metadata and time period when you need this. Okay, so in this time here you can see we already discussed. Suppose I need the image for the Dhaka city, and suppose I need the image only for the less than 1% cloud cover. I need the image for that year of 2017 for a specific time or any specific time. Using this 3 factor, we are just filtering our image collection. So let's go. So in this time, this result show for the whole world, but I don't need for the whole world. I need only for my region of interest, suppose Dhaka city or in a specific boundary. So here I already import my boundary shape file. So here you can see I already import my boundary shape file. How we can easily import the boundary shape file, I already show you the previous class. So just simply click on here and then I simply import this boundary shape file. So you can see it look like that. I just simply click on the import button. Just click on the import. So now it imported. Okay, and it show the default variable name is the table. Okay, table is the default variable name. You can put any name as a variable. Suppose I put the name is that ROI. Okay, or you can put any name as a variable. So now this image collection show the result for the whole world, but I don't need for the whole world. I need only for the Dhaka city area, Dhaka city boundary. Okay, so for that I just take a variable. Suppose I put the variable name is that filter region. Any name as a variable. I put the name is the filter region, then equal sign. So this is my full image collection. This image collection is stored in a variable. What's the variable name? L8. You can see when I print the L8 and use the size function, then I can get this image collection. So this image collection is stored in the L8 variable. I simply copy the L8 and paste here. So now from this L8, I need only for those images which images are available in the Dhaka city boundary. So for that, I use a function filter bounds function. Okay, so filter bounds function, basically it intersecting with your whole image collection to your region of interest. What is the argument about that? This argument is the geometry. Okay, so in shapefile boundary and call the filter region and paste here, then use the function size function. So click the run. So now it's computing how many images are available in the Dhaka city. We find out, you can see 444 image collection. Okay, so it also decrease the image size. So now suppose from 444 images, I need only for this image whose image is the less than 1% cloud cover. I filter the image metadata. I choose only for those images whose image is the less than 1% cloud cover from 444 images. Okay, so for that I just take another variable, suppose filter metadata. You can put any name as a variable, and then from 444 it is stored in this variable filter region. I simply copy and paste here, and then use a function filter metadata. Okay, and you can see what is the argument about that for filter metadata: name, operator, and value. What is the name? Name basically your image properties name. And where I find out the image properties name? You can easily find out. You can see image properties. So all of image properties we can easily find. But in this time, I want to use the cloud cover. So just I simply copy the cloud cover. And further, I just put here that cloud cover and put the operator name. Suppose I put the operator is that less than, and put the value, suppose 1. So now from 444 images, it show me only for those images which image is the less than 1% cloud cover. So now let's check. We check how many images is the less than 1% cloud cover. So further, simply copy the filter metadata and paste here, and then use here the size function. Click the run. So now it's computing how many images is the less than 1% cloud cover in my region of interest in Dhaka city. We find out 67 images is available for that in my study area. Less than 1% image. Suppose I simply increase the less than 5%. Now check how many images about that. So click the run. So you can see in this time this is also increasing. We can get the 116 images, less than 5% cloud cover. So always we try to get the low cloud cover imagery for getting the very cloudless imagery, and it also look more working. We can easily do it. We can get the better accuracy. When you want to remove all of cloud, we can get the very better accuracy for land use, land cover, or other industries. So we try to put the very low cloud imagery, suppose less than 1. But sometime when you want to work for the river bank or coastal area, then you did not find out this type of less than 1% image is not fine. It show the totally 0. Okay. Suppose when you want to work for the coastal area or river bank, you put here the less than 1%, then you find out it show the 0. It means that for this study area, there is no image which is less than 1% cloud cover. So then you have to increase the cloud cover level. Okay. When you increase the cloud cover level, then you find out the image. Otherwise, it show the 0 when you put the 1. Okay. But in the Dhaka city, we can easily get, you can see less than 1% image is available. And how much image? We find out the 67 images are available for my Dhaka city study area. Okay. So now this 67 image, what is the duration? This time duration is that year of 2013 to 2024 for whole time period. We find out total 67 images are less than 1% cloud cover. But I need to for a specific time period. Suppose I need the image for year of 2017. I need the image for year of 2018. So any specific time period, how I can filter. For doing these things, we are just take another variable. Suppose filter date. You can put any name as a variable, equal sign. And this image, 66 image, is stored in a variable. What's the variable name? This variable name is the filter metadata. Simply copy and paste here. Then use the function filter date function. And in this time we put here the start date and end date. Okay. I put the start date, suppose year of 2020 1st January from year of 2020 December 31. Okay, so now let's check how many images are available between this time period for 1 year. Let's go print and call the filter date, copy and paste here, and further use the function size function. Click on. So now it show you that how many images is available for the 1 year in Dhaka City. We can get only for the 7 images are available. Okay. So here you can see, first of all, we find out the very large number of image collection for the whole world. When I filter it for my study area on Dhaka City, I can get the 44 images. From 44 images, I choose only for image which is the less than 1% cloud cover. I find out the 67 images. From 67 images, I choose only for those images which image is the available for year of 2020, January to December. I find out the 7 images. So this is the process for filtering. First of all, this filtering we call as a where. Suppose where you need this image. You need the image Dhaka City, you can simply put the Dhaka City shapefile variable name. In this time, ROI is stored at my Dhaka City shapefile variable name. I put at the ROI, where you need this image. I need the image in the Dhaka City. Then, how you need the image. How? Basically, I need the image less than 1% cloud cover. So it's how. And then finally, when. When you need this image. You need the image, suppose year of 2020 from January, December, or any specific time, month of January, February, or any specific summer. So just put the time. So basically, where, how, and when. We are just apply, and then we can easily filtering the image collection for any region, So where, basically, where you need the image. I need the image Dhaka City. So that's why I already imported the Dhaka City boundary shape file in here, ROI. Okay, it is stored. You can put any name as a variable. And further, how you need the image. I need the image less than 1% cloud cover. So I put here. And when you need this image, I find out this type of time period. We can get the total 7 images. Okay. And this 7 images is not captured at the same time of the year of 2020. So the acquisition date is different on the year. Suppose this 7 images is not captured at the same time of the year of 2020. So if the acquisition time is different. So for that, I want to check all of images individual acquisition time. So for that, simply print this filter date and click the run. So now it shows you the result, all of images, acquisition time, all of details you can easily get from here. Okay, so here you can see, just click on here, image. So basically, we find out that total 7 element, mainly 7 images, and all of images have total 17 bands. Just I click on here. So now I can get, you can see this type of result. So just I simply So now you can see here, we can get the first image, year of 2020, 11th February. Okay, 26th January, 11th February, 30 March, 27 December. 9 November. We can get also that time. Okay, not only for that, I simply click on here, then I can get all of properties for my individual images or single images. Just click on here, I can easily find out that what is the cloud cover, what is the cloud cover length. So all of information, data, you can see about the time, about that. Okay, so all of those things we can easily access for the information from my image, individual image, we can easily get it from here. Okay, you can see there's a lot of information about this image. So now suppose I want to work only for this image. Suppose this time period image, year of 2020, 11th February, this image I want to work. I want to visualize this image in my map. So what can I do? For that, simply click on here and you can see the ID. Okay, so also you can see every image have an ID. You can see the ID. Also you can see this image also have the ID. Suppose this image, year of 2020, 11th February, I want to display on my map. So simply copy this ID from here. Just copy this ID and further write a code in here. Just take a variable. Suppose image. You can put any name as a variable, equal sign, ee.image. Okay, and further paste this ID which you copy. Okay, so now I want to display this image. I want to add a layer. We already know about that. Further, we have to use a function map.add layer. and in this time it's an image, because this variable I simply copy and paste here. Okay, image. So basically this image I want to visualize, so that's why I put at the map.add layer and then call my object. So this is my object. So now click the run, you can see it added a layer but not focus on my center. For focus on the center, we have to use a function map.center object. Map.center object. Suppose I want to focus on my study area, which is RY. Put the zoom level, suppose 10. Click run. So now it automatically focusing on my study area, and it also display this image tiles. So here you can see we can get this type of tiles. Okay, and this acquisition time is that year of 2020, 11th February. We can get this image tiles look like that. And it also, you can see it also cover my study area of Dhaka city, these tiles. So now it show for as a tiles, but I want to show only for my study area of Dhaka city boundary. For that, I have to use the clip function. Okay, suppose I simply use a function clip with my study area. Study area mainly RY. RY is stored at my boundary shape file. Click to the run. So now it just clip with my study area, and I got the image for my Dhaka city boundary, and it look like that, totally black color, because you can see I don't add any kind of visualization parameter. So it show the default visualization color, this type of things. So now I want to add the visualization. Okay, I want to use the different types of band combination, and I want to add the different types of band combinations. So for adding the band combination, you can see about that setting button. Okay, so just click on here, and I set here, suppose band combination, I want to set for red, then put at the green. Basically before is the red, then green, and put at the B2 is the blue. So it's called the RGB or natural color. Okay, and then I put the stressing 98% for better looking for the data, and then apply it. So now we can get the natural color imagery look like that. You can see it throughout the natural color. We can easily identify all of these things from here. Okay, it's show the natural color. We can easily use the different types of band combination. Just simply change the channel of the band name. Then it show the different types of band combination. Suppose I want to show the another near infrared. Then put at that red and blue. Suppose stressing 98%. And further just apply. So now you can get the false color band combination. You can see you can get this type of color. Okay, so we are using the different types of band combination from here, and it's very important to make the identify for the different type of feature from the surface. So basically we are using the different types of band combination to identify different types of object from the satellite imagery. So I will discuss a lot of time when I work with land use land cover classification. Then I will explain all of those things, how we can easily work with that. So in this time, I put here suppose before red, green, and blue, and custom stressing 98%, and further apply. So now you can get this type of visualization. But here you can see this visualization I want to import in my code editor. Okay. So for that, you can also get the another option. You can see it's called that import option. You can say import. Just click on the import, a new line of code added in my code editor. You can see it will be added. It variable name is the image this param. I simply copy this variable name and paste after the object name. So in this time, my object is the image. Then I put at the visualization parameter variable name. Then I put the layer name. I put the layer name suppose true color. Click the run. So now you can see it added the layer true color and also set the visualization. Okay, let me run again. Okay, so you can see it added the visualization in here. Look like that we can get. Suppose I want to add the another visualization for the false color. So for that, click on here again and set the band combination. Suppose near infrared, then red and blue, custom suppose stressing 98%, and apply. So now we can get the false color composite look like that. In this time, vegetation show as a red color, water body show as a black color or dark color. Okay, so now I just simply import that. You can see when I click on the import another visualization parameter also added. Okay, so just I simply copy it and I take the another layer. Suppose I want to visualize the two layer, true color and false color at the same time. So for that, simply copy the same code. I simply copy and paste, and I put here the this parameter 2. I put the suppose layer name. Click the run. Layer here you can see about that. Just uncheck it, then it will show about that. Suppose you want to add the another visualization, simply click on here, and further I put here suppose short wave infrared 1, P6, then near infrared, and then suppose green, and custom stressing 98%. So now apply. So now it shows this type of another band combination. It's very useful for identify for the cropland vegetation. So you can see you can get this type of visualization. We can easily identify about the barren land or wetland. We can easily get this type of feature. So I also want to import that. So just simply click the import. You can see another visualization parameter also added in here. So just I simply copy these things, and further I want to paste. I take the another layer. So just add a new layer. So just I simply copy the same things from here and paste here, and I put here the suppose 3. So it's the another band combination. I put the suppose another band. Click run. So in this time we can get the 3 layer. Okay, so we can easily visualize the different types of band combination. Okay, after adding the image. In this time you can see here I use only for the single date image. Okay, it only for the single date image. Sometime when you want to work, you need only for the single date imagery for your analysis. So for that, you are just use the process to get the single date imagery. Okay, so click on here, then you can get about all of imagery. You can see about that feature. So from here, which date image you is better for you, simply copy this ID and work with that. Okay, suppose some work when you want to do, you need only for the single date image. So this is the process for showing the single date image. Okay, single date. In this time I talk about that how we can easily create the composite such as mosaic or create the median composite. So these type of things how we can easily create. For creating the composite in this time, suppose here I find out how many images. You can see here I find out the total 7 images. Okay, so these 7 images I want to make the composite. Just I make the median composite, all of images, and create the single image. Okay, single median composite image. So for doing these things, for creating the median composite, just take a variable. Suppose I put the variable name is that final image and equal sign, and I call the filter date. Okay, basically this filter date is protect the 7 images. In this time I want to create the median composite using all of 7 images. So just I simply copy and use a function median. Okay, so basically in this time this median function create the middle pixel value all of total 7 images and create a composite. Okay, and further I just click with my study area which is ROI. So now further I simply add a layer, map dot add layer, and call the final image. Simply copy and paste. So in this time it create this composite, but it not any single date image. It's just a median composite, and this median composite is created from total 7 images middle pixel value. Just combine and create this median composite. Okay, because I use the median, and this filter date is created total 7 images. So all of 7 images make the median composite, single image median composite. And further I click with my study area and visualize. So in this time here you can see it added the another layer. I simply uncheck previous layer. So it create the median composite. Okay, in this time this image have total 7 images middle pixel value and create this composite. So now I just try to show you the visualization. Click on here again. I set the visualization suppose red, then green, and also blue. After the custom is tracing 98%. and further apply. So now we can get this type of true color composite. But in this time, this image is not the single date image. This image is the created using all of total 7 images. Median composite it create. Okay. So now you can easily use here the different types of band combination about that. And it's very important for the median composite because you need the satellite image for whole country boundary of Bangladesh. Okay. And one single tiles is not enough for the whole country boundary of Bangladesh. Okay. So then we have to use the median. Okay. So all of image we create the median, then it will be fill up our whole study area. Basically, it's need when you want to work for the big study area. Suppose you want to work for the whole country boundary of India. So one tiles or one single image tiles is not enough for your whole study area. Then all of image we just create the median composite. Then we can get the satellite imagery for the whole country boundary of India at the same time. Okay, but for the small area, suppose Dhaka city or any other small area, we just cover the one tiles. Then you can easily use the single date image. But for big study area, such as any country boundary, such as India, Bangladesh, or any specific big area, when you want to apply, then single tiles image is not enough to cover your full study area. So for that, we have to use here the median composite. Okay, median composite, it combine all of tiles and create this final imagery. So it's very important when you want to work for the big study area. But single study, small area, we can easily use the single date imagery. So this is the process for single date imagery, how we can easily get. And this is the process how we can easily create the median composite about that. Okay. So now anyone any question or any confusion, you can ask me about the full code. Okay,
Okay,
so yeah.
what about by meaning stretch? 98%.
Yeah. So 98% stressing basically is one kind of data visualization process. Suppose when I put at the 98% stressing, then this data is the stressing and show me the visualization. Suppose stressing is one kind of your visualization process. Suppose when I put at the 100%, then it creates the 100% stressing. 90%, then it creates the 90% stressing and show me the visualization about that. Okay, suppose basically mean and max. Suppose you can see it's a mean and max. It's the show about the range. Suppose 98% when I stressing, then I can get this type of range. Okay, and this type of range, I find out the better visualization. Suppose when I put the 100% stressing, you can see this range also change. We can get we can get this type of range. Then I can get the visualization, this type of range about that. Basically, wavelength range about that. When I put it the 90%, then we can get this type of range, and it also show about the visualization when I apply that. So basically, it's one kind of visualization process. Sometimes some work we use here the 98%, then we can get that better visualization. Then we use here the 98%. Sometimes stressing 3 sigma, then we also get the better visualization. Okay, so you have to check. Okay, so which visualization is better for your map. So within this time I put the 98%, then I can get the more better. So then I use it, no problem. It's a one kind of visualization process.
Okay, thank you.
Yeah.
Yes, sir. What is the difference between print function and map add layer? Like when to use print function and when to use the map add layer?
Okay, so map.add layer, it's one kind of function when you want to visualize. Suppose I want to visualize this image. Okay, and this image, final image is stored in here. I want to add the layer. So this image I want to add the layer. So then I use here the field map.add layer function. And print function, basically I want to print the image collection. How many images are available in my collection? Suppose filter date. How many images is available? I want to check it. So for that I call the filter date and use the size function. So now it's computing 7 images. But I want to check all of information for the 7 images. Then I simply put here the print and call the filter date variable. So then it provide me all of 7 images information. All of information from the total 7 images. You can see, just click on here. Then you can get also show about the 7 element, mainly 7 images. Now it show about all of information. But when I put the size, then it only computing the value, how much images are available. Okay, and map.add layer, suppose after creating the image, so in this time you can see when I put the median, so then what happened? Median, basically when I put the median, then all of image create the median composite. This composite I want to visualize, so that's why I simply use the map.add layer function and then visualize it. And in this time, suppose you print that, suppose I simply use the print final image, you can see how many images stored in here. It show only for the one image because one median image. So click the run. In this time we find out one image, and this one image is created from total 7 images. So here you can see this result. Yeah, you can see, okay, one image, and this one image have total 17 bands. Okay, one image. And in this time, suppose I just put here the size function, you can see size function is not working this time. Just click the size, you can see it show about that wrong, because size function only work for the collection. Okay, but when I put the median function, then this variable is not stored in any collection, it's just a single image.
Okay, thank you very much. And just yesterday I asked you like how to deal with the red marks. So this is the example, like line 20, final image size is not a function. So how to like find out where the problem is?
This problem is the size function, because size is only work for that collection. Suppose you simply search there, just simply search there about the function size, and then find out the size function. What about say about the size function? You can see size. Click on here. You can see returns the number of integers in dictionary. We find out that dictionary and integer value. Okay, if image collection, you can see this is another feature collection in the size. So returns the number of elements in the collection. Okay, so without collection, size function cannot work. Okay, you can see return the number of elements in the collection. So in this time, it's not a collection because it's a totally single image. After applying the median, I just get the single image, single median composite image. So it's not a collection. So that's why in this time it show about that final image is not a function. So just in this time I cannot use the final size function. Yeah.
Yeah, how to deal with that, like how to remove this red, like where to intervene or where the problem is, how can I understand that?
Okay, you have to practice about that. Suppose in this time, you simply search there the size function, and you can see about that. Actually, size function work, you can see it show about the feature collection. Okay, so size function only work for the collection. Suppose you can see I already use the size function. It also work in say the 7 image collection, 7 image collection. It already work. But when I create the median composite and I try to apply the size function, then it will not work because this size function only work for the collection. Okay, so you can simply search all of function, not on map.add layer or any function. Simply search on the docs tab, then we can get the document. Suppose you can see about that filter bounds function. I simply search there filter bounds function. So you can see about the geometry. So filter bounds argument is the geometry. It can be any kind of point, line, polygon, okay, or shape file. We can easily import as a filter bounds, as a polygon. You simply click on here, you can see shortcut. It can filter a collection by intersection with geometry. Okay, so in this time, I already make a collection. You can see L8 is my collection. Okay, this collection I want to intersecting with my study area, which is ROI. So for that, I simply call the L8. Then put it the filter bounds function and ROI. So now this image collection is intersecting with my ROI, and I can got only for those images which are available in my study area.
Okay, thank you very much. And so last question, like how can I easily memorize or understand like which functions to use? For example, filter bounds or whatever.
Okay. So for that, like you simply remember about that. Suppose where you need this image, for that you have to use the filter bounds function. How you need this image? Less than 1% cloud cover. For that you have to use the filter metadata function. And when you need the image for a specific time, you need to use the filter date function. Okay, just simply practice 1-2 times. You can easily get it and not memorize anything, because when you memorize you forget after 1 month, 2 months. Just you realize that. Suppose where you need this image, I need the for the where we use there the filter bounds function. mainly it intersecting with my whole image collection. And filter metadata function, basically it's filter your image metadata. Suppose I need the image less than 1% cloud cover. Suppose I put, and you not to memorize this type of things, because when you write the function, suppose filter metadata, I simply write in here and press Control space, I can get all of argument. Okay, I can get all of argument about this function. What is the argument about that? We can easily get. You can say the name, operator, and value. What is the name? Name mainly image properties name. You can easily get the image properties name from here. You can say the image properties and check all of image properties name. Okay. Operator. So basically, it's the less than 1% cloud cover. Simply put here the less than 1%, then put the value about that. So you don't need to memorize anything. Just you can check all of argument and what is the tax about that. So basically all time when you filter any satellite images, we have to use the filter bounds function, filter metadata function, filter date function. So it's the basic. When you filter any satellite imagery, it depends on your study area, it depends on your cloud cover level, it depends when you need this image. Mainly filter date function. Okay. So
Okay, then when you write like less, there is underscore after less
Yes.
underscore there. So if I don't put this underscore, what will happen? Like
it not
just
work.
less than.
It not work. Suppose click the wrong.
Yeah.
In this time it
Yeah.
not work.
So there is a pattern or there is a like system to write.
You can see
those.
the cloud cover, or also underscore about that. Also you can see about the cloud cover. You can see in the underscore in here. Okay, underscore in here. Yeah. And then put at the less than, also under is the underscore. Okay. Suppose also you can see the camel case about that. You can see AP is the lowercase, B is the uppercase. You can see the AP is the lowercase, M is the uppercase. So it's called the camel case. So one is the lowercase, then another letter you can see uppercase. Okay, and you can easily visualize. You can see when you write the correct function, it show the purple color. Okay, suppose filter bounds a function, it's a purple color. Suppose I put here the lowercase b, then you can see it not show the purple color. Okay, suppose I put here the lowercase m, so not it show about the purple color. And when you did not show the purple color, it means that your function have a problem. You did not write the correct function. So for this region, this code editor is very powerful, because we can easily identify this function have a problem. But this type of things you cannot get when you want to use the Python, because suppose I Python here the uppercase, it also same. Suppose I put here the uppercase, we can get the same color, or if I use here the lowercase, we can also get the same color. We did not get the understand about that. But in this time, when I put here the lowercase, it show about this type of color. Okay, but all of function all time will be purple color. Suppose I put here the uppercase m, so now you can see we can get the correct result about that. So that's why it's very easy way we can understand about that all of function, and we can easily remember and we can easily identify our problem. Suppose anytime you write the wrong function or wrong spelling or wrong pattern, then it show about it not show about the purple color. Okay, all of function. Suppose you put here the in here uppercase and then put here the lowercase, you can see it show this type of color. So it means that your function have a problem, because function color always will be purple color. So then you can simply check the function spelling, just simply search there, suppose filter date, you can see about the function. You can see first one is that lowercase, then uppercase. So according these things, simply put these things, then it will be working. Suppose I just write in here again, filter date, you can see first one is the lowercase, second one is the uppercase. Okay, field F lowercase, D is the uppercase. Okay, so this is the process to do this type of things. Okay, just you just practice 1 or 2 times. I hope you can easily get this idea.
Okay, so and where to put the dot, like metadata dot filter date, then dot crop
Yeah,
dot.
I will go in this time in here. So in this time here you can see when I just take a function, I take the new variable. When I take the function, I also take the new variable. When I take the filter date function, I also take the new variable. In this time, we don't look like that. We are just take only one variable, and on this variable, you can put all of argument one by one. We can put all of argument. So let's check how we can do it. For the first time, I write this type of code for your understanding. But in this time, I just take only one variable and write all of function using the dot notation. So let's go simply commenting full code. And then further, I want to just take the only one variable. Suppose I take only one variable L8. Okay, this variable I store all of function. So first function, filter bounds function, and there is no matter about the space. Spaces doesn't matter. You can write it or you cannot, no problem. So spaces doesn't matter for the JavaScript, but in the Python, spaces also matter, because when you want write the Python code, it also depend on your space. But for the JavaScript, there is no problem for the spacing. You can write the function anywhere. There is no problem. Suppose you can write in here filter bounds function and bounds with ROI. Okay. If you want, you can also write the same line, or you can put at the space, more space. There is no problem. Okay. So this is my image collection. This image collection, I simply filter bounds with my study area, which is ROI. Okay. Then I simply put the another function dot notation and put at the filter metadata and put at that cloud cover, which I easily get from here. You can simply copy and just write in here cloud cover, and then put at that less than, I put at the suppose 1. Okay. Further, when I need the image for filter date, put at the start time, suppose year of 2020 of 1st January from year of 2020 December 31. So now you can see this is my image collection. This image collection I want to filter according to my region of interest. Where I need this image, I need the image Dhaka city. So I call my Dhaka city shapefile variable name. And how I need the image less than 1% cloud cover, I use the filter metadata function. And when you need this image, I need the image for year of 2020 January to December. So now you can see where, how, and when I apply, it create the image collection. Suppose image collection, I simply put at the print and call the LA and use at the size function. So now it show me the final result, how much image I want to get, all of condition. I can get the 7 images. Okay, filter bounds function, filter metadata function, and filter date function. After applying all of function, I find out total 7 images. But you can see when I write the code one by one, you can easily understand how it will be filtered one by one, how it will be filtered. But if you want, you can just take only one variable, and in this variable, you can simply put your function, filter bounds, filter metadata, filter date, and you can get the final how much image is stored in the L8. We find out the 7 images. And now I have to check about the all of information. Just simply use the print and put the L8. Now I can got only for that information, total 7 image information, acquisition date or single image. Suppose you need to work with a single image, just simply copy the ID and then work with that. Just copy this ID and just apply the same process which I already show you for the single date image. Okay, I hope you can get this idea. And then I want to create the median composite, just use here the median. In this time, you can see what happened. After put the median, this variable is not stored in the collection. This variable is stored in the median composite, median single composite. Click to the run, you can see it show about that size is not a function. Because when I apply the median, then L8 is not a collection. It's just a single image. Okay, it's just a single image. So that's why in this time size function cannot be worked. Size function only work for that collection. But when I put the median, then it all of total 7 image collection create the your middle pixel value and create this median composite and store it in this L8. So that's why L8 show the is not a function. So in this time we are not applying these things for the image. For the image, size function cannot be worked. So I just print the only L8. So now you can see image mainly single image, and this single image have all of band, total 17 bands, B1, B2, B3, all of band we can easily get from here. So now I want to visualize it, same process, just use here map.add layer. And you can see here, suppose I did not put the median, but I want to add the L8. In this time, it also not work. You can see it also work, but in this time, all of images show in here, not create any kind of single image. You can see all of total 7 images. You can see it show about that. Okay, this is study area, show about all of images. And I also put here the suppose clip function. In this time, you can see clip ROI. Clip is not working this time. You can see it show about that. Image collection, filter bounds, filter metadata, filter date, clip is not a function. Okay. clip is only work for single image. Okay, clip is only work for the single image. Okay, but in this time you can see don't create the single image. Okay, because you can see when I put the size function it also work. Okay, it will not work because we have to. Okay, so it's not problem. Okay, in this time you can see about that it's a median. I just commenting this thing, so that's why median is not work. Median is not work. Okay, and then I just clip with that, then it not work because clip function only work for the single image. Okay, in this time I just simply uncheck these things, median image, I create the median single image, and then I just clip with that, so now it will be work. You can see now it will work. Now it will work. But first time you can see in the collection, I cannot apply the clip function. Suppose I have a collection and this collection I want to use the clip, then it not work. Because clip function is only work for the image, single image. Okay, suppose you can see when I take the single date image, it's only for the single acquisition image, single date image. I directly use that the clip function. Okay, because it's a single date image, it's not a collection. But in this time when I just put here the median, and after the median I don't use the median and then clip with that, then it a collection, LAT is a collection, and collection clip is not work. Just click, then you can see to show about the problem. So for that, this collection I need to must convert into image. So how I can convert the image? Just I simply use the median. So now it create the median single image and then clip with my study area. So now click the run, it show the result. Okay. So further you can simply add the visualization from here. Suppose click on here and add the color band, suppose B4, B3 and B2. Customer stitching 98% and apply. So now we can get this type of map, true color composite. So further we can easily use the image for do the different types of remote sensing analysis. For land use, land cover, or NDVI or NDW, anything we can do from here. Okay. And now I have to
why the color is showing like this, like looks like water, but if you take this image to ArcMap, I think like it gives a better visualization.
It's also like depend on the resolution. Okay, in this time this resolution is 30 meter. Okay, 30 meter pixel resolution, but when you want to work for the sentinel, then we also get the more better image. Suppose sentinel is only for the 10 to 12 meter resolution, so that's why this visualization is also depend on our resolution. So Landsat is a 30 meter, so that's why you can get this type of things. But when you want to put the sentinel to satellite imagery, then you also get the more better image.
No, so I said like if you download this same image and display on the ArcMap, it will show a better visualization than this. Like, so is it like by default, like with the Google Earth engine, that the images are shown like this?
No. So when you download this image also, you can also get the more better. Suppose I download this image and try to open in the ArcMap or QGIS, then you also get the more better about that.
Yeah, that's what I said.
Yeah, that's a better.
And sir, when you write the code, like you put double slash and single image, for example, then it becomes green. So like if you put like this at the beginning of the function, then it means a comment, right? But if you put it this after the function, it doesn't mean a comment, right? The function works properly. For example, like print, where the cursor is now, print, and then double slash, and then that means it will not work.
It's just a comment. It's just a comment about that.
Yeah, but after that, like with the single image, you see after the clip, there's double slash and then single image.
Yeah.
So in that case, it will work, right?
So it's also comment. Suppose when I use this type of syntax or this type of symbol and write any line, so this it just this part work as a comment.
Okay.
Suppose I just remove that, in this time you can see it already show about the wrong. But when I put here that it's called the line comment. Suppose line comment. Okay. When I put this in here, then clip is also comment. In this time clip is also not work. Suppose when I put at the median, it also not work.
Okay, thank you.
Okay, so anyone any question about that? Okay, I hope you can easily get the idea how we can easily use the clip function. Clip function only work for the single image, and clip is not work for the collection. Yeah. Okay, so I hope you can easily get this idea how it will work. Yes. Okay, any question about that? Okay, I think everything is clear. Yeah. How can you classify? Okay, where do you filter bounds? Okay, just you need to practice.
Yeah,
Okay, then we can.
you already answered it. Like, no worries. Thank you. And do you have any list of the like commonly used functions, like the one what you are using now, like filter, bounds, etc.?
Okay, so basically you can get the documentation from this type of documentation, but in our online training program, I will provide you a lot of code. Suppose this type of practice code I also provide. So then when you practice, then you can easily get the lot of function. And basically, this is the things about that all time. All time we use here the filter bounds function, filter date function, filter data function, filter date function, median function, reduce region function. So all of I hope after completing this online training program, if you learn all of function properly, you can do any kind of remote sensing analysis. Do any kinds of remote sensing analysis. Because in this online training program, I will show you all of practical example. So this type of example you can easily do for your own study area. Then you can easily learn a lot of things. Okay, you can easily cover a lot of function will be covered from here. In this time we are not talk only about that user interface, because user interface, this function, suppose I will show you that. Suppose this, just simply search there UI, it called the user UI. Suppose UI. Suppose you can see UI. In this time we will not talk about the UI. Suppose UI level, UI chart, UI. So otherwise almost all of things will be covered. UI.map. So basically this type of user interface, mainly this type of function need when you want to work for that web application or remote sensing different types of web application. So that's why anyone can use your web application and get the lot of data, water quality web application or drought monitoring. Okay, then we have to use this type of function. Okay, with that UI function, I will try to cover all of things one by one. No problem. Okay. So this is the code about that. And okay. Oh yeah. So it also covered. So basically we already published our syllabus. Okay. So it will come one by one, all of those things. So here you can see we talk about our land use land cover classification class in that our 6th day. When I talk about the machine learning model, then I also try to discuss about that how we can easily work with the supervised and unsupervised different types of algorithm, how we can apply and create the classification. Okay. Then I hope we can really get this idea about that. It also covered, no problem. Okay. Okay, so now I hope you can really get this idea how it will be work. So now I want to export this image. Suppose this imagery I want to export, and further I want to work for other software. Okay. Suppose this imagery, all of band, I want to export, and further I want to work for the QGIS or ArcMap software or any other satellite imagery about that. Okay, I'll also show you the export, how we can easily export this satellite imagery, export imagery. So I write the comment. So in this time, okay, so before that, I'll show you another example. It is more better. Suppose you also try. So in this time, you also try for the Landsat 9 also, how it will filter, Landsat 7, Landsat 5. So this type of image collection you also try, because it's the same process for filtering for the different time, and also give some assignment regarding this things. You also try. Then I hope you will learn about that. Suppose how to filter Landsat 9, 8, 7, 5. Okay, this type of imagery you also try to filter. Same process for filtering. Now I talk about that modis. Suppose modis. I will show you only for the one data set for filtering, how we can easily filter. Using the same process, here all of data set you can filter. All of data set, FD, all of data set. Okay, so I'll show you only for the one data set, but you can, using the same process, you can filtering and visualizing the snow cover daily map, land surface temperature map, or vegetation index map, also evapotranspiration map, any kind of data set you can easily filter and visualize the map. You can see the net evapotranspiration map, Okay, Tranet, evapotranspiration aspiration map. Okay, all of image collection you can easily work for that. You can see the LST, trial land surface temperature. There's a lot of data set in the modis. We can easily work about that, but it's not a good resolution. Okay, so this is the problem about that. But it's available for the globally. For the big study area, we can easily do for more better map. But suppose you need the work for the small study area, suppose Dhaka city or more small area, then this type of modis dataset is not work well because this pixel area is very high. The resolution is very low. So that's why it's another problem. But suppose you want to make the map for the whole country boundary of Bangladesh, India, or any big study area, then this dataset also provide a very good quality result. But for the small area, we did not get the good quality map because this pixel area enlarge. Okay, so now check the practical example. Suppose I want to show you this part, any specific data set I want to work for. You can see there is a lot of data set. Suppose I want to work for this data set. You can see graph vegetation index is 60 global, 250 meter resolution. So this resolution is 250 meter resolution. And I just click on here, then I can get all of information about this data set. So here you can find out the data set availability. You can see you can get the data set from this time. And this is the last time about that. So also you can see dataset provider is that you can click on here, then you can get the more information about the dataset provider. And you can say that Earth engine snippet. So basically this is the unique ID about this dataset. Okay, we already know about the unique ID about this dataset. And you can set all of information, description about this dataset. Here you can see this dataset is already marked for water, cloud, heavy aerosol, and cloud shadow. So that's why when you use the data set, you don't need to filter any kind of cloud cover level or aerosol or any cloud shadow. You don't need to remove because it's already removed. Okay, it's one kind of ready-made data set. Just we are using here. And in this time, when you use this data set, you not put any kind of formula or equation because we already know about the NDVI have a formula. NDVI equal to near infrared minus red divided by near plus red. But in this time, when you use this type of data, we find out the ready-made data set. Here you can see it show me the band about the NDVI, EVI. Okay, I can simply use it and you can easily identify about the vegetation. So now how it will work. So I'll show you the practically. Then I discuss about the export, how we can easily export the at the same time. I will try to show you that. There's a more better understanding about that. So just I simply open a new code editor and discuss about that. Okay, so first of all, here you can see about that your artisan snippet unique ID. Simply copy this unique ID, just copy. Okay, and then paste on your code editor. So now it paste. Now take a variable name. You can put any name as a variable. Suppose I put the variable name is that suppose NDVI modis. You can put any name, but in the variable name you cannot use the space. You can use the underscore. There is no problem. But suppose I put here the NDVI and modis, I put the space, it already show about the wrong. Okay, so without a space, we simply put here the underscore. So this is my image collection. So this is my image collection. This is my image collection. And now it is stored in the NDVI modis. Okay, and this image collection have a two band. Here you can see band NDVI and EVI. I want to work for NDVI. I simply copy the band name NDVI and then I just paste here. Just use the select function. Basically, select function used for selecting the band. I want to select only for the one band of NDVI. So just I put here the NDVI. So now you can see again, this is my image collection. This image collection have a two band NDVI and EVI. I want to work for the NDVI. So just I simply use the select function and select the NDVI. Okay, so now further you can see this image collection data this time period 2002 2024. Okay, so now I have to check how many images available for that whole time period. I simply put the print and call the NDVI modis and use here the size function. So now it computing in this collection how much images are available. So now let's check. We find out total 557 images for the whole world. Okay, in this time I just need to filter this image collection for a specific time period. So for that I use a function I just simply put the space. There is no problem. Just use the filter date function and put the time. Suppose year of 2020, 1st January from year of 2020, December 31. So just I put this 1 year. Click the run. You can see how much image I got for the 1 year. 23 images, because it's the, you can see 16-day global. 16 into 23, it almost 1 year. Okay, because time interval is that 16-day. Suppose first image is that 1st January, second image is the 16th January. Suppose I just print that, only print this NDVI modis. So now I got all of information about my image. You can see about the image equalization date. All of this we can easily get from here. Total 23 images. You can see about that feature. From the feature we can easily get about that. You can see the 1st January, 7th January, 2nd February, 18th February. So every, you can see what is the interval about that. 16-day. So that's why this data set called the 16-day global. Okay, because it's a 16-day. We can find out the 16 band. You can see one band, only for the one band. NDVI, which I select in here, it's on the NDVI. So now this is my image collection, and now I want to make the map. Suppose I just put here map dot add layer and call the NDVI modis, NDVI image, click to the run. So now it loaded the map for the whole world. In this time you can see there is no problem. It's a collection, but I directly show the result. NDVI modis. There is no problem for the whole world. You can see it look like that for the whole world NDVI map year of 2000. Okay. So now I want to add the visualization, suppose color, so that I can easily identify about that high and low. So they already provide some demo color. You can see I simply copy their demo color code. So basically they are make a dictionary in here. Just I paste here. So you can see they are make a dictionary. In this dictionary, they are put here the mean and max value of NDVI, and also put here the some plated, color plated hexacode. I simply copy this variable name and paste after the object name. So this is my object. I simply paste in here after the object name. So now this color set with my map. Click the run. So now we can get the colorful map of NDVI for the whole world. We can easily identify what is the high vegetation, what is the low vegetation. It shows for the whole world. Again, it shows for the whole world about that. Okay, it shows the whole world about that. We can easily identify about that for the whole world NDVI map. But in this time, I don't need for the whole world. I need for a specific area of interest. Suppose a specific shape file or a specific boundary. So how I can get it? Very easy. Previous class I discussed about one data set which is called that US data set. Basically, it's provided with international boundary polygon. So in this time, I get the international boundary polygon and choose a specific country, and further I want to clip with my study area. Then I can get the result only for my boundary. So just I import that. It will import, you can show the table. So this table I want to filter. So previous class discussed about that. I just take a variable, suppose RY equal, I call the table. I want to filter. How I can filter? I want to filter art engine dot filter dot equal. Okay. So what's equal what? I put here that country NA. I put the country name, suppose Bangladesh. Okay. So now what happened? This variable RY is stored at the Bangladesh country boundary. Okay. This RY. So now you can see here when I just clip with my RY, it show a problem. So just I clip with my RY, click the run. It show a problem. This problem is that clip is not a function. Okay. It show the problem. So now what's the solution about that? This solution, you can see for the whole world, it worked very well. For the whole world, we can easily get the result. For that, when I remove the ROI, clip these things, it will be work. Suppose click to the run, it will be work. For that, I run the code again. So you can see it will be work for the whole world, and we can get the very better result. But when I put here the clip function with my study area, then it creates this problem. Okay, then it creates this problem. Okay, when I clip with my study area, suppose I clip with my study area ROI, it show the problem. It show the clip is not a function. For this function in this time, we have to use the another technique. It's called the reducer. So in this time, we can see NDVI modis is a collection. Okay, it's a collection. So now I want to check it. Suppose you can see how much image collection I can get in here. Just I simply print that. Just print NDVI modis. Use at the size function. Click run. In this time, we can get that how much image? 23 images we can find out. So now this 23 images I need to reduce. And how I can reduce? For reducing that, in this time I want to calculate it that average pixel from all of 23 images. Suppose this 23 images I want to create the average. I want to create the average NDVI map. Because this 23 image is not captured at the same date. It's captured the different time. Create the different time of the year of 2020. So for that, 23 is my image collection. Okay, it's my image collection. This image collection I want to reduce. So how I can reduce? I want to apply the average function and reduce it. So in this time we talk about the new function. It's called the reduce. Reduce is an statistical function. It calculates the mean, max, minimum, standard deviation, this type of things. When you calculate, we have to use that the reduce. So basically reduce is an statistical function. It helps you to calculate from the mean, average, maximum, minimum. These type of things will be calculated in here. Okay, so reduce is a statistical function. In this time, I want to calculate the 23 image average result. Okay, so for that, I just take a variable. Suppose I put the variable name is that average NDVI. Okay, and I have to calculate the average from these 23 images. Okay, it comes from this modis NDVI modis. Simply copy and then paste here. Further, I use a function reduce. Reduce is a statistical function. Then I need to define how I can reduce. I want to reduce using the average function, reducer dot mean. Okay. So now, first of all, I define the reduce. Then how I can reduce? I define from total 23 images. Okay. So now it is stored in this average NDVI. I simply copy and paste here. Okay, and further I clip with the study area. So now we can get the result only for the Bangladesh boundary.
And so one question here, like after reduce, why didn't you put a dot here?
Which one?
After reduce,
Yeah.
and then why didn't you put a dot here after reduce? Like after modis you put a dot, but after reduce, like you didn't put it in dot. So
Okay.
why?
Yeah, so reduce, it's a dot notation for connecting with this collection. It's a 23 image collection. I just connecting this function reduce. So that's why I put here the dot notation for connecting that. Okay.
No, I mean like after reduce, like why didn't you put any dot? Do you have to put any dot here, like after reduce? Yeah, here?
No need, because in this time, it's a full part. Okay, suppose you can see we already use this type of function in our filter depth. You can see here filter. Yeah, you can see here filter. How I can filter? I define it in here. Same things we also put in here. I want to put the reduce. How I can reduce? I define
Okay.
it.
Okay. Thank you.
Okay, so now you can get this type of result. You can see here. It shows the Bangladesh NDVI map year of 2020. Okay, suppose I put the another country. Suppose I put here that Pakistan, click run. So now it automatically show the Pakistan, but not focus. So I want to set the code for focusing. We already know about that. Map dot center object. Object is that my shapefile variable name ROI. Put here the 10, click run. So now it automatically focusing my study area.
I have a question.
Yeah, please.
So NVIDIA is calculating the vegetation index, right?
Yes.
So vegetation index, so vegetation cover is different in different seasons in the whole
It's a ready-made code. It's a ready-made code. Okay. So basically, it's depend on your. It's a ready-made code, but when you want to use the your specific time, then we also get the different season, different NDVI or vegetation.
No, my question is why are you averaging the whole year? Because like NDVI map that is 23 is from different time, like from different periods or
So
seasons.
you can
So
put here
it
your time
will,
period in here, then also work. In this time, I take the total 1 year. So you can put your own specific season or your period, then you can make this. Okay.
but I didn't understand why are you using the average thing like
So
your
without average, here you can see if you don't average or reduce this image collection, then you cannot visualize it. Okay. So in this time, we already show you that it not show about the clip function, because when you apply the clip, you must need the reduce your image collection. This 23 image is not captured at the same time. Okay. So it captures the different time of the year 2020. Is it okay or not?
yeah.
Yeah. So this image is the capture for the different time of the year. And now I want to reduce it. So then I calculate the average pixel all of imagery. Okay. Suppose we can check about that how much image we can get the 23 images. And it said 23 images is the capture for the different time of the year of 2020. So that's why we are just make a reducer. So in this time, suppose you want to show visualize about the maximum vegetation result, just put here the max. Then what happened? Suppose it's a single image. Okay, I'll show you that. Suppose I just use here the these things. I remove the size and then click run. So in this time, we can get all of imagery in here. Just click on here. From this feature, you can see the 23 images we can get in here. In this time, this is the one single image you can see. It's a one single image about that, and this time you can get the one image. So in this time, this one image, I want to calculate the what is the average. Suppose each image provide you the average pixel. Suppose from this image I can the average pixel. Second image it also calculate the average pixel. Third image it calculate the average pixel. So all of image create the average pixel and display this type of average NDVI map. But when you put here max, suppose I just put here the max, then it calculates. Suppose this image calculate the maximum NDVI value. This image calculate the maximum NDVI value and create this composite. Okay. And it's a ready-made data set. So that's why we can just put our time period and we need to reduce it. You can simply search there, then you also get the more better idea about the reducer. Suppose you can see reducer, reduce. Just I click on here. You can see apply reducer to an array by clustering all of the input values along each specific axis into the single output value compute by the reducer. Okay. So now we are just applying here that specific argument. Suppose I need to calculate about that mean or maximum or minimum. Okay. Then we can just use here reducer. Okay. And without reducer, it not visualize. Okay. Suppose if I don't put here the reducer and I want to clip with my study area, then it's not showing. Suppose I just simply remove that and I want to average NDVI. I want to just simply call my modis NDVI and then paste here and clip with my study area. In this time, this modis NDVI is not reduced. It show all of images. So click run. In this time, it show this type of problem. You can see it show about that clip is not a function. Okay. So for this region, we need to reduce our image collection. Reduce mainly we create the single image. Single image, it can be average single image you can create or maximum single image you can create or minimum single image you can create for NDVI or any other data set when you want to work. Just remember that you need to make the reducer when you want to clip with your study area. So for this region, we try to apply here the reducer and call this our final output Click on, so now it works. Okay, so a lot of time we use the reducer for the different purpose. Okay, so now I show this type of map. Yeah.
So this reduce function are averaging 23 image to one image, right?
Yes, yes. All of 23 images make the one image.
Okay, so you're averaging like the whole year.
Yeah, whole year. Yeah. Okay. Suppose I put the another country. So all of country, we can simply visualize what is the condition about that. We can get the result from here.
Sir,
Yeah, please.
so what is the difference between the mean function and the max and the average function? Like here we have used mean, that is the average.
Yeah, average.
But if we have used max function, then what would the result represent?
So now, suppose you can see this is the image. This is the one single image. So this image have a two. Suppose in this time when I put at the mean, then total 23 images average result it show in my map. When I put at the max, from total 23 images, maximum pixel of NDVI show in my map. When I put at the mean, then it show me about that all of total 23 images minimum pixel value and create this map. Okay, when I put at the mean, then all of modis NDVI state my total 23 images. All of 23 images create the average pixel and create this single map. Okay, but this map is created from total 23 images average pixel value.
Sir,
Yeah, please.
if you put after reducer mean or max, it means from out of 23 images, only minimum and maximum image will be represented.
No, in this time it create the composite, look like that composite, who is composite. Suppose in this time here you can see, when I work this code, I just show you that the total 7 images, we create the median composite. Okay, so median is another kind of reducer. Okay, because in this time all of total 7 images create the middle pixel value and create the single image of the median. This same concept also put in here. Okay, not much different, same things also put in here. Okay,
So these two are different examples, right? Median and this mean.
Median is an statistical. It calculates the middle pixel value, and average calculate the average pixel value.
Okay.
Yeah, max is calculate the maximum pixel value. Minimum calculate the minimum pixel value. Yes.
But sir, what is the difference between this reducer function as a whole and the one that we were doing previously, dot median or dot mean previous? Like.
Okay, I will explain. I got your answer. Suppose in this time you can also put here that mean also, no problem. Okay, it generates the same.
Okay.
But as a good coder in Google Earth Engine platform, they are always write here the proper way to write the code. First of all, I reduce my image collection. How we can reduce? Then I define it. Okay, but it provides the same result. Okay, any question? Or any confusion? Okay, median function. Okay,
Sir,
it's already done, yeah.
could you go to the code editor again?
Yes.
Yeah, here, like there is one curly bracket and there is one square bracket. Like if I want to if I want to merge them with the orange line, what will happen? Like, will it work or not? Like, I personally don't like this, like to be like this, like in a separate line, only brackets. If I merge this like with the backspace, with the line, with the numbers, what will happen? Like, will it work or not?
Which one? I don't understand. So actually, it's a dictionary. In this
Yeah,
dictionary,
you see, yeah,
yeah,
this two.
yeah.
These two brackets, yeah.
Yeah.
If I reduce this, use the backspace in the left, in the keyboard, and yeah,
Space
use
is
the
not problem.
backspace.
Space is not problem. No problem.
No, okay.
Space is doesn't. You can also take the more space. Also take the
Okay.
more line space. No problem about that. So in this time here, they make a dictionary. Dictionary, we already know about that. It has the keyword and key value. Keyword and key value. And dictionary, we can also add a list. Okay. Suppose you can see it's a list, a square bracket. They make some color plated list. Okay, square
Yeah.
bracket, and then make the list about that. Okay, so yeah, then you can simply copy the variable name and paste after the object name.
No, I mean, like, can you take this curly bracket and square bracket to the number line, like the orange number line, using the delete function? Could you put your cursor at the last of 301, like number,
In here.
just in the upper line? No, 2 lines upper.
Yeah. Yes.
More 2 lines upper. Yeah, more 1 line upper. Yeah, yeah. If you put the cursor at the last, like 301, like the last number, yeah, in the same line.
There is no problem. No problem. No problem.
Okay.
Actually,
I
space doesn't matter for the JavaScript programming language. Okay, you can put the more space. There is no problem. You can write the more space. No problem. Space is matter only for the Python.
Okay.
Okay, there is no problem about that.
I understand.
Okay. Okay, so now we can get this type of result. So any country, we can easily get this type of things from here. But this map have a problem, and it's a serious problem. This problem is that you can see when I click on here, I can get this type of result. It show about that 3097. It show about that, but we already know about that ND value cannot look like that, because ND value difference between -1 to +1 all time. This is the range. Okay, but in this time it shows this type of things. Okay, so this is a problem. How I can solve this problem? For solving this problem, first of all, we have to know about the scale about this data set. So this scale is that here you can see they are already provide some scale. You can see this is the scale value about that 0.001. So this scale value I want to multiply with my whole image collection. Okay, so in this time you can see my image collection have total how many images? 23 images. We find out. Okay, this 23 images I need to multiply with my image collection. Okay, how I can apply the image collection for that? So in this time I have to use the concept of function. We already discussed about the function, how we can easily create the function. In this time I just create a function. This function help me to calculate, basically multiply all of images, 23 images, multiply with the scale, then it will work. So in this time I create a function. This function, it calculate all of those things at the same time. You can also do the random way. Suppose without function, how I will show you that. It take a lot of time. Suppose you just take a variable, suppose image 1, and call your ID. Suppose you can see this is the one image. I simply copy from here this ID. Just copy from here, and then I just put here ee.image and multiply these things, and then further multiply 0.0001. Suppose I take the second image, bar image 2. I simply copy the second ID. Just you can see about that. Another image, copy this ID, and I put here again ee.image and put here, and then multiply with the same value, because scale is the same for all of images. Okay, so now it takes a lot of time, because in this time I take only for the 1 year, but when you want to work for the 5 years data analysis, 10 years, then what happened? Then it creates also more large number of image collections. Suppose I need the result for year of 2015 to 2020. Just I put here 2015 to 2020. Total 5 years data I want to get from the MODIS, and further I create the average NDVI map. Okay, suppose I need this type of things. Then what can I do for that? So it creates a lot of imagery. Suppose I click to the run, you can see how many images I can get for that. for the total 5 years, year up to you can get the 138 images. So in this time, if you want to put here the one by one, it take a lot of time. Okay. So for that, in this time, we are just reuse our code and use the concept of function. Okay. So let's go how we can easily create the function. So we already know about that function. So just take a variable. I put the variable name, suppose scaled ndvi. Just put it scaled ndvi. You can put any name as a variable. Then put the equal sign and put here the function keyword. In this time, I put my element. Suppose here 138 images. If I take the element image 1, then image 2, image 3, up to suppose image 138. It also takes a lot of time. Okay. So for this region, in this time, I just take only for the one image. Suppose I take the one image. Okay. I take the one image because all of image I need to multiply with the same scale value. So, and this image I want to, what is my argument? I define it in here. So my argument is that I want to return this image, multiply with my scale value, which is 0.001. So just put here 0.0001. So in this time, you can see about this code. I just take a variable name, function. I put the element name. I take only for the one image, and this one image I multiply with the scale. Okay, but in this time, I consider only for the one image. What about for other image? For the other image, what can I do? For other image, I just take the another function. It called the copy properties. Copy properties. And what is the copy properties? Copy properties mainly copy your properties after multiply. Suppose when I multiply this image, it creates the one kind of unique properties. Okay, these properties I copy. Okay, so just I put here that img. Okay, so I just copy this image properties. So put here the img and apply these properties from start time and end time. Okay, so basically start time is that and end time is that. Okay, basically between this time period we find out total 138 images. So just I apply it. So just put here the system time start, and also put here the system time end. So here you can see what happened. System time start and system time end. Here I already defined my start time and end time. System basically it's called, this code is also called as a system. So in this time, this is my system. I already defined a start time and end time. Okay. And between this time, how many images I got? I got total 138 images. Okay. And this I just apply it in here. So I again explain, you can see. So first of all, I take a variable name, equal sign, put the function keyword, I put the element name. I take only for the single image, one image. This single image I want to return, multiply with my scale value, and then after multiply it create the new properties. These properties I copy and apply start time to end time. Is it okay or not? Any problem about that? Or any question you can ask me about the code? Okay, any question? Because it's very important, because for the lot of time I use this type of function. Okay, because for the lot of conversion or lot of change the unit, so different time we are also use this type of function. So that's why it's very important. Okay, so I hope you can got this idea. So in this time you can say I create my function. Okay, it's my function, and this is my function variable name. This is my function, and this is my collection. Okay, this is my collection, and this is my function. It totally it's not any connection. Okay, there is no connection between the collection and function. In this time, I just need to make a collection, make a connection. How I can make the connection? I simply copy the variable name, because it's my collection, total 23 image collection. This collection I want to connect with my function. Just paste here and use here the map function. So basically this map function help you to connect with your collection. This is my collection, 23 images, and this is my function which I created. This function now apply on this image and it's in this variable name. Okay, So you can see this is my collection. I use the map function and connect with my collection, which function I created. So all time, suppose you can create any function. This function you need to connect with your collection, image collection. Then we use the map function and put our collection variable name.
So Sam, you are just connecting more than one function here, like map,
Yeah.
multiply, and copy properties.
Yeah. Yes. And basically system start, it means that in my collection, I already defined this time period. Okay. And in this time period, how many images I got? I got total 23 images. Okay. So now when I put at the modis NDVI, it comes from the 23 images and apply and multiply all of images with my scale factor 0.001. Okay. Is it okay?
What exactly is copy properties doing?
Copy properties in this time, I just simply multiply with my image. It create the new properties. Suppose this, I multiply these things, it create this type of properties, image.multiply 0.01. Okay. So these properties I copy. These image properties I copy and apply this system start and system end. Basically, it's my start time and end time, which I already define in here. Okay, so copy properties basically copy your properties from after multiply.
Okay, thanks.
Yeah. Okay, so any question?
So why do